So we're going to review the definition of a function. And remember, every relation has a domain and a range. And it's usually x's and y's, but it could be anything. What does it mean to be a function? So if I have a series of x's and a series of y's, each x hits only one y. So if I write a new function, is that a function? Yes, it is. Because every x hits only one y. Is it okay that there are several y's that have x's, the same x's? Yeah, that's okay. And the analogy we used before is every person only lives in one city. It's okay if a city has more than one person in it. So to be a non-function, we would need to have something like this. This x is attached to two y's, which means it's not a function. So there are two worksheets you need to pick up. One of them deals with functions, and I think there are 15 problems you need to decide, does that describe a function or not? Go for it. So let's look at number one. So number one says we're going to create a function of a person's name versus their social security number. So if we create two columns, we listed all of the people in the United States and then social security numbers, would that create a function? CJ, why not? And it would have to be the exact same name, first name, middle name, last name. So if there were two people that have exactly the same name, they're two different people, so they'll have two different social security numbers. So that would not create a function. So that would be no. What if I said people in the United States versus social security number? That would be yes, but it said names. So that would not be a function. Okay, what if we invert that? What if we bring the SSN over here and we bring the name over here? Yes, that would be a function. How come? Right, so that would be every social security number is linked to only one name. But there might be multiple social security numbers linked to the same name, and that's okay. So sometimes a relation is not a function, but its inverse is. And sometimes a relation is a function, but its inverse is not a function. All right, number three, the cost of gas versus the amount of gas pumped. So let's say gas is $3.77. If I pump a gallon, will I always pay the same amount? Yes, until the price changes, but that would be a new function. So this one is yes. For every amount of gas pumped, there's only one amount to pay until they change the price, but that would be a new function. Good. Number four. There are two fours. Is that a problem? They both go to 10. So number four is a yes. Is the inverse a function? We'd have multiple 10s, but they both go to 4. So that is a function, and its inverse is also a function. Yes or no? Yeah. We're explaining. So all you need to write is yes or no. Okay. Number 5, the time of day with respect to the temperature. So if it's 75 degrees at 1 and 75 degrees at 2, is that okay? Yes, because it's two different x values. My x values are times. Can there be two 1 o'clocks? Yes. So we have to kind of decide. Are we talking about a single day? Well, let's pick a 24-hour period. If we pick one day, is it a function? Yeah, oh, good. That's good. We would need to differentiate between 1 a.m. and 1 p.m. Okay? So if we do that, is it a function? Yes. What if we look at the whole year? No. Could we turn the whole year into a function? Well, we're still doing time versus temperature. Date and time. So if I said the 19th at 1 p.m. and the 20th at 1 p.m. and they're the same, they're different values, is that okay? Yeah, that would be two different x's. So it kind of depends on how you label your x's. Good. So depending on how you interpreted this, it could have been yes or no. All right. Number 6. No. Why not? A 6 goes to 2 and a 6 goes to 5. If I invert this, is it a function? Yes, because all of the x's are unique. Number 7, the area of a circle as it relates to the radius. So if I pick an area, so let's say 2 square feet, how many radii are there that will create a circle of 2 square feet? Just one. So this would be a function. If I change the area, it changes the radius, but there's only one radius per area. Good? Number 8. Yes. Is the inverse a function? No, it's not. Okay? The radius of a cylinder is dependent on the volume. So this is radius of a cylinder versus the volume. No, why not? So here is my radius. How many cylinders are there with that radius? A lot of them. So here's one. So let's say that my radius is 3 inches. Can I create more than one cylinder with this radius? Yeah, I can create lots of cylinders. So this would be no. What if I flipped it around? What if I gave you the volume of a cylinder? Does that guarantee a single radius? No, how come? It could be short and fat or tall and skinny and have the same volume, but it would have two different radii. So that one doesn't work either way. Number 10, the size of the radius of a circle dependent on the area. That's the inverse of 7, right? On 7, we said, given area, is there only one radius? And the answer was yes. What if we give you a radius? How many areas are there per radius? Just one, so this is a yes. So 7 worked, and its inverse also worked. Number 11, students' letter grade and the percent. So a bunch of people in this class got an A. Did everybody have the same percentage? No, in fact, probably nobody had the same percentage. So 11 was a no. Would the inverse work? Percentage versus letter grade. Yeah, if you have 86%, you get a B no matter what. Unless I don't like it maybe, and then maybe a B minus. Number 12. The length of fence needed with respect to the amount of area to be enclosed. Okay, I have a no. Explain yourself. So you change the shape. So if you change the shape, you can change the area using the same amount of fence. Somebody said no. Nobody dares. There's something it didn't tell us. Okay, if I said I have 40 acres, how much, on my 40-acre property, how much fence is going to need it to go all the way around it? Could you get more than one distance on that? No, how come? And you already know the shape. So the question here is, the length of fence needed with respect to the amount of area to be enclosed. It depends. If they give us a shape, is it a function? Yes. But if they just say 21 acres and they don't tell us the shape, then it would be no. So that one could kind of go either way depending on how you interpret the question. 13, we'll skip that. The answer is no. You don't know how to do that yet. We'll get there. Somebody, you know it? Oh, okay. 14. This is a really strange function. If x is a rational number, then it's linked to the number 1. If x is an irrational number, then it's linked to the number 0. Is that a function? I hear no. How come? Changed your mind. So this is what the function would look like. Here are my x's and my y's. If I had 1/2, what does that match to? That one gets linked to 1. If I have the square root of 2, that gets linked to 0. If I have pi, 0. If I have 6.34, 1. If I listed every possible rational and irrational number, is it going to be a function? Yes. How come? That's the key. Can a number be both rational and irrational? No. So if it's rational, it always goes to 1. If it's irrational, it always goes to 0. The only way to break the function rule is if I could put a number in both categories. And there are no numbers. Rational and irrational numbers are mutually exclusive. You're one or the other. You cannot be both. You can't be a fraction and a non-fraction at the same time. Okay, number 15, the national debt with respect to time. No, how come? Can it? That's the key, right? Has the national debt ever come down? So let's say that our national debt looks like this. Would the national debt versus time be a function? Yes, because every year it gets bigger and bigger and bigger. So if I looked at all of the values of the national debt and compared them with the time, then it would be yes. But if at any time the national debt comes down, then let's say this is $1 million. Yeah, that was a long time ago. So that $1 million might have happened in June. It might have happened again in August because we paid some, and then when it went up, it might have happened again in October. So has the national debt ever come down? Well, we're always paying some of it. We just don't ever pay enough of it. So in your lifetime, no. But historically, has the national debt ever come down? Yes. Probably not during Abe Lincoln's time. I'm sure during the war, the debt was heading in the other direction. Okay, so this one is no. It's not a function because the debt has come down before. Not recently, but it has come down before.